Good morning, students. Now, today we have to continue once again derivative. That means applications of derivative. As we are familiar with the meaning of dy by dx. So, meaning of dy by dx in mathematics, particularly, it is nothing but slope of tangent to the curve at a particular point or a given point. So, as far as that curve is concerned, suppose line L is tangent to the curve at point P x1 y1. So, you know the definition of tangent. So, line which touches to the curve at a point is called tangent to the curve, and the common point between the tangent and a curve is called point of contact. So, here P is a point of contact. Now, next one we have to consider that line M, which we call it is the normal to the curve. That means the line which is perpendicular to the tangent at the point of contact only. So we have to just consider normal to the curve. So definition point of view, a line which is perpendicular to the tangent at a point of contact only. So is called normal to the curve. So just as we consider slope of tangent, then for any curve it is nothing but dy by dx, and slope of normal, because of perpendicular, it is minus 1 upon slope of tangent. Now we have to just consider the equation of tangent and normal to the curve. So equation of tangent and normal to the curve can be calculated by using slope point form. So as we know the slope point form, y minus y1 equals to m into bracket x minus x1. So slope of tangent to the normal, or you can say as far as that m is concerned. So by using that we can calculate the equation of that tangent or normal. So some examples: find the equations of tangent and normal to the curve at a point on it. Now first one example, that equation of curve, it is given x square plus 2 into e raised to x plus 2 at that particular point 0, 4. So we have to first calculate dy by dx. That means in general slope of tangent. So if we differentiate that y with respect to x, then 2x plus 2 into e raised to x. 2, it is a constant, so derivative is 0. So we have to calculate slope at that particular point. So dy by dx at 0, 4 it is. Put the value of x is 0 and y equals to 4. So definitely it becomes 0 plus 2 into e raised to 0 point of view, it is 1. So slope it is 2. So slope of tangent to the curve at that point it is 2. Now we can calculate slope of normal to the curve. It is minus 1 upon slope of tangent. So it becomes minus 1 by 2. That means slope of tangent. So we can consider that point it is 0, 4. That means x1, y1. So equation of tangent and normal to the curve by slope point form. First one for tangent, y minus y1 equals to m into bracket x minus x1. So you can put the value of m, it is 2. So y minus 4 equals to 2 into bracket x minus 0. So y minus 4 equals to 2x. Therefore 2x minus y plus 4 equals to 0. For normal, same format, but slope is different. It is minus 1 by 2. So it becomes 2y minus 8 equals to minus x. That means multiply to both sides by 2. So finally it becomes x plus 2y minus 8 equals to 0. Now you have to solve certain examples which are solved in the text, and also these two examples, second and third. At that particular point it is given. So you have to calculate with the similar fashion. Now next we have to consider some examples in the another form. Means parametric equations we have to consider. So find the equation of tangent and normal to the curve in the following at given point. Now here x equals to sine theta, y equals to cos 2 theta. Theta it is a parameter, no doubt, so value it is given pi by 6. So we have to calculate that equation with same fashion. So therefore we have x equals to sin theta, y equals to cos 2 theta. Now you know how to calculate dy by dx for parametric equations. So dy by d theta upon dx by d theta. That means differentiate that y with respect to theta. So it becomes minus sin 2 theta into 2, and derivative of that x means sin theta, it is cos theta. So if we put the value of that sin 2 theta, it is 2 sin theta into cos theta. So cos theta cancel. Finally it becomes minus 4 sin theta. But we can put the value of that theta equals to pi by 6. So minus 4 into sin pi by 6. Pi by 6 means 30. You know sin 31 by 2. So finally dy by dx at theta equals to pi by 6 equals to minus 2. That means slope of tangent equals to minus 2. Now again you can calculate slope of normal. Minus 1 upon slope of tangent. So equals to minus 1 upon minus 2. So slope becomes 1 by 2. Now point you can calculate. It is not given. Theta it is given only. So x1 y1 means sin pi by 6 and cos 2 into pi by 6. That means point it is 1 by 2 comma 1 by 2. Now the equation of tangent and normal once again by slope point form is for tangent y minus y1 equals to m into bracket x minus x1. So y minus 1 by 2 equals to minus 2 into bracket x minus 1 by 2. Multiply by 2 to both sides. So as far as that value it is concerned, now once again as we consider that value, then definitely we can calculate the equation of that normal and tangent. So for normal, y minus y1 equals to m into bracket x minus x1. So y minus 1 by 2 equals to 1 by 2 into bracket x minus 1 by 2. Multiply by 2 point of view. It is 2y minus 1 equals to x minus 1 by 2. Again multiply by 2. So 4y minus 2 equals to 2x minus 1. So modification 2x minus 4y plus 1 equals to 0. So once again you have to solve certain examples of the same type which are given first and second, and solve again some solved examples in the text. Thank you.